Okay, thanks for confirming. So
Yes.
let us start the session. So yesterday I have told you what are the topics that we were discussing, right? So I've told you what are the GCP basic concepts that we were discussing, what are the data engineering concepts that we were discussing. So in today's session, we are going to start with one of our first topic, why we need the cloud platforms. Okay, some basic idea I will try to give. And after that, I will tell you what are the GCP interfaces. And after that, if one wanted to interact with any of the services in the GCP, how he can able to interact with. Okay, so let us start it. So you might have already know few of the things here, but let me just recap so that you will be able to understand better. So assume that you are working in one of the company. Okay, let's just consider you are working in one of the company, and that company wanted to roll out a new application. Okay, a company you are working on, that company wanted to create or roll out a new application to their users. Now what will happen, let us try to understand. So they wanted to create an entire new application from the scratch for their users so that the users can take benefit of that particular application. Now what will happen is that for that application, if they wanted to create it, the business comes up with a requirement for the application. Businesses comes up with a requirement for the application, and he will pass on that information to the business analyst. Now the business analyst gather the needs from the business and analyzes it and converts it into a set of high level technical requirements, and then he passes that information to the solution architect. First, the business comes up with a requirement for the application, and then business analyst will gather the information from the business and analyzes it and converts it into a set of high level technical requirements and passes that information to the solution architect. Now we all know that solution architect is the one who creates the entire architecture design to be followed for the deployment of this application. Okay, the solution architect, what he will do, he will try to gather all the information from the business, and he will convert that information into a architecture diagram to be followed for the deployment of that application. When I say architecture diagram, it may typically include the infrastructure such as the specification type, the count of servers, the front-end web server or the back-end web server, and the databases that they have to use, the load balancers. So all of these information will create one solution architecture diagram so that all teams will follow the diagram to be able to create one entire new application. But what happens now, the programming team or application team, they will try to create the code, but the infrastructure team will be there. There are two types of teams. One is infra team, one more is development team. Infrastructure team will have to focus on the infrastructure based on the solution architecture diagram, and the application team will try to create the code for this application. Right now, if that entire infrastructure, think about the infrastructure team, if that entire infrastructure is already available in the company, okay, that company is already having its own data center, because if you go for 10 years before, we do not have any cloud platforms. All the companies has to have their own data center. When I say data center, it will be having a rack and stack. A rack and stack where you will be having CPU, RAM, storage devices, networking components. Plenty of these things are coupled together. That's what we call as a data center. Okay, so what the infrastructure team will do is that infrastructure team will check it, whether the entire infrastructure that is required for the application is available within the data center or not. If it is already available within the data center, then there is no issue. But if it is not available, what the solution architect will do is that he will create a request to the procurement team. Okay, so what they will do? They will try to create a request to the procurement team. So this is what we are talking about a traditional model, sir. In a traditional model, you will be having the deployment to be done in your own data center. Okay, you have to make use of your own assets of your data center. If anywhere the architecture diagram requires a new hardware, then they have to be ordered it via procurement team. Now this team will put in a new request to the vendors. Now it will take days or a weeks or even months for the hardware to be purchased as well as delivered it to the data center. Okay, so what is happening? The solution architect will create the diagram, and whatever the infrastructure required for this particular application deployment, if it is already available within the data center, then there is no problem. They will directly deploy it in the data center. But if it is not available, if they need of additional hardware, they have to order it via procurement team. And now this team will put in a request to the vendors. Okay, so it will take months or it will take weeks or months also sometimes for this hardware to be purchased. They have to purchase it. Vendors team will be there, guys, right? So they have to purchase it. They have to deliver it to the data center. So this would take a lot of time. Once that is there available in the data center, once that entire data center, once the entire infrastructure is available in the data center, the infrastructure team will come into the picture now. Okay, the infrastructure team will come into the picture. Once the entire hardware is received at the data centers, the field engineers are in charge of the rack and stack of the equipment, and the system engineers will do the initial configuration of the system, and network admins will do the network configurations so that the entire system to be available over the network, and storage admin will assign the storage to the systems. Backup admins will take care of the backup of the entire storage. Finally, once the entire things are set up as per the standards, it will be handed over to the application team. It will be handed over to the application team. The application team will be deploying that application on top of this ready-made available the infrastructure. Okay, so that is how your application is now deployed in your own data center. So that is the reason it is called as a traditional working model. In a traditional working model, the entire infrastructure required for your application needs to be purchased and available in your own data center only. Okay, so this is what is a typical traditional working model, where if one company wanted to roll out a new application, the business comes up with a requirement. The business comes up with a requirement of the application. The business analyst will gather the information and converts into a set of high-level technical requirements. The solution architect will create a solution architecture diagram to be followed for the deployment of the entire application. And if the infrastructure is already available, then there's no problem. If it is not available, they have to put in a request to the procurement team, and procurement team will create a request to the vendors team. Vendors team will take a lot of time to be purchased and delivered to the data center. Once it is received at the data center, field engineers will take care of the rack and stack. System admins will take care of the initial configuration of the system. Network admins will do the network configurations to make all the system to be available over the network. Storage admins will take care of the storage. Backup admins will take care of the backup of the data, and application team will take care of deploying the application on top of deploying their code on top of this infrastructure. Okay, so this is what we call as a traditional working model. It is called as a traditional working model. In a simple words, if I have to say, traditional working model is nothing but deploying your code or an application within your own data center. You have to, the organization has to manage its own computation power to deploy its own code or an application. So that is what we call as the traditional working model. But what is the problem, sir? I say that everything seems good, but what is the problem with the traditional working model? In a traditional working model, if you can see here, it is a very slow deployment model. Because if I have to create a one more application, I have to go through all of these things. Many teams are working, many people are working. There is a dependency. There is a dependency on the infrastructure. There is a dependency on the multiple teams also. So the turnover time varies from the weeks to the months to be everything ready for the application deployment. So the turnover time varies, guys. So if I wanted to create a new application, not only that, if I wanted to scale it also, for example, my application is doing very good, but if the application is doing very good, that means the users are very interested in our application. If I wanted to increase my resources, or if I wanted to reduce my resources as per the requirement, but we cannot be able to do it that much easily. It takes a lot of time because everything is not available in the data center. We have to be again purchase it, deliver it to the data center. It takes again events. It takes again months, and that's how. So whenever you wanted to create a new application from the scratch, or if you wanted to scaling up and down as per your infrastructure demand, it cannot be achieved quickly. So that is the reason it is called as a slow deployment model. It is called as a slow deployment model. It is because everything is not available. If we there's a dependency on the infrastructure, there's a dependency on the multiple teams. And one more important aspect is that this traditional working model is very expensive comparatively. That the overall cost to deploy and maintain this working model is very high. The overall cost to maintain and deploy this application is very high. That's the reason we called as a traditional working model is expensive. Some aspects of the infrastructure is automated, but some aspects of the infrastructure cannot be automated. So that is the reason we call it as a limited automation. Because you look at the field engineers. So such kind of activities, what they do in the field engineers cannot be automated because we have to do the rack and stack cabling and the networking, all those features manually. So several steps such as rack and stack cabling, other deployment procedures has to be done manually. So that's the reason it is called as a limited automation. Okay, only a few aspects can be automated fully, but some of the aspects cannot be automated. So that is the reason we call as a limited automation. And with so many teams working with on the so many different tasks, the chances of human error are very high. Okay, many teams are working. You are seeing it here, right? So you have a business team, you have a field engineer, system engineers team, a storage team, backup team, application team, data team. So plenty of the teams are working behind the scene and have many different tasks. The chances of human error is very high, which results in inconsistency in the environment, which leads to inconsistency in the environment. And one more major disadvantage is that you are going to waste the resources. This is called as the underutilization of compute resources because whatever the resources that you bought today, you may not be using 100%. So that leads to the underutilization of the resources. In other words, wasted resources. Okay, so this is what is a traditional working model, guys. In a traditional working model, the working model is slow deployment model. It is very expensive. The overall limitation is very less. Limited automation. Human error is there. Leads to the inconsistency in the environment. Underutilization of the resources. So these many disadvantages that are there over the past decades. So that is the reason organizations wanted to looking for a one more alternative solution for the traditional working model. So they don't wanted to work on the traditional working model. They are looking for an alternative solution where they don't wanted to take care of all of these things, because taking care of all of these things, it's very costly, slow deployment, limited automation, human error, wasted resources, plenty of disadvantages are there working on the traditional working model. Okay, so that is the reason the companies are looking for alternative solution. So that's where you got cloud providers. Okay, so that's where you got the cloud providers. What they say is that you don't need to maintain your cloud data center, we will take care of it. Okay, you don't need to maintain the data center, we will take care of it. You don't need to purchase the hardware, we will take care of it. You don't need to do the rack and stack, we will take care of it. You don't do the initial configuration, we will take care of it. You don't do the system admins, storage admins, backup admins, you don't take care of it. You can directly focus on application development. You don't need this thing, 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 you don't need this thing. Okay, so when the application team, that means when a new application is required, businesses pass on this information. This is required, so there is no procurement team. So a solution architect will design the architecture diagram. Now there will be a DevOps team will be there. There will be a DevOps team. What they do is that they create the infrastructure with the help of this cloud infrastructure. And on top of this infrastructure, the application team will deploy it. That's it. We don't need to procure, we don't need to create a request to the procurement team. We don't need to worry about the vendors. We don't need to worry about purchasing it and delivering it to the data center. We don't need to manage the data center 24/7. We don't need to manage the data center electricity. We don't need to worry about the data center water supply, cooling, all of those things we don't need to do. And field engineers, we don't need to worry about it. System configurations, network configurations, so storage admins, backup admins, we don't need to worry about anything here. We can directly focus on the application team, directly focus on the application development. DevOps team can focus on the infrastructure development with the help of the cloud provider. So the cloud providers came into the picture. They say is that we will provide the cloud computing services to you. We will provide the cloud computing services to you to try to create your applications, deploy your applications with the cloud computing services. So that is what is cloud providers. So one of the three leading cloud providers are, we have AWS, Azure, and GCP. Okay, we have three leading cloud providers: AWS, Azure, and GCP. Okay, so now you got some idea why we need the cloud platforms. With the help of the cloud platforms now, with the help of the cloud platforms now, the working model is not slow, because the working model is very fast. You don't need many teams, as I told you already. You don't need this guy, you don't need this guy. No, 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 sorry, no. So this is we need, guys, this is we need, this is no. So the deployment model will be very fast. It's because scaling up is very easy. Creating a new solution from the scratch is also very fast. So that's the reason it is a faster deployment model. So the disadvantage is not there. And it is not so expensive. Whatever the resources that we need, we can create the infrastructure with the help of those resources only. I don't need to worry about the data center water supply. I don't need to worry about data center cooling, 24/7 electricity. I don't need to put in a request to the procurement team. I don't need to worry about field engineers. I don't need to take salaries for all of those people. So because that is the reason, it is a not costly process. It is a less expensive process. And when you are working in a cloud platform, everything works via APIs, application programming interfaces. So that is the reason the automation is very high. So that disadvantage is also not there. And here, as you see that earlier when you are working in the traditional working model, many teams are working behind the scene. But now very less teams are working behind the scene. The chances of human error is not high. So it does not lead to the inconsistency. You do not have that human error here, but very less. It will be there, but very less comparatively. And wasted resources will not be there. It's because whatever the resources I need it, I can only create those resources. And there is a requirement from the cloud provider. There is a one more concept of scaling up and down. If you needed 100 GB, you can select only 100 GB. Tomorrow you need 200 GB, you can select 200 GB. There's no problem there. You can only pay for 200 GB. Today you can only pay for 100 GB. So there is no wasted resource concept. There is a wasted resources, but very less compared to the traditional working model. Okay, so that is the reason that disadvantage is also not there. Okay, so this is how when you're working in a cloud provider, when you are using the cloud computing services, the deployment model is faster, less expensive, high automation will be there, less human error will be there, and there is a good utilization of the resources will be there. Okay, so this is how the difference between the traditional working model and cloud computing or cloud provider. Okay, in single shot, I have to say what is the difference between the traditional working model as well as cloud computing. If you ask me, sir, in on-premises or a traditional working model, an organization managing its own infrastructure to run their own application. If an organization managing its own infrastructure to run their code or applications is nothing but a traditional working model. In an on-premises or a traditional working model, the company has to manage its own infrastructure to run their applications. Sir, what do you mean by infrastructure? Sir, some people will ask me. Sir, infrastructure can be a server, can be hardware, software, networking, storage, CPU, RAM, all of those things. So if an organization managing its own infrastructure to run their code and application is nothing but a traditional working model. If a organization is depending upon the services delivered by the cloud computing, that is what we call as a cloud computing working model. So if an organization dependent on the services provided by the cloud provider, that kind of a model is known as a cloud computing working model. In a cloud computing working model, cloud provider deliver the infrastructure as a service to the company. What they do, the cloud provider will deliver the infrastructure as a service to you. You are going to utilize those services. Okay, so this is what is the difference between the traditional working model as well as cloud computing working model, guys. Okay, if anyone have any questions, you can ask me, guys. You can put it in the chat or you can raise your hand. I will ask you if you have any questions on this one until why we need the cloud platform. So when I say why we need the cloud platforms, I told you this entire step because you need to know when you are working in a company, you should know what is happening end to end. What is happening end to end. If you understand what is happening end to end, that actually gives you tomorrow you maybe become the solution architect, right? Throughout the down the road, you are going to become the solution architect. You should know from now onwards, being 3 years, 4 years, 5 years of experience, you should know what is happening in your entire workflow of creating your application. Okay, what we are doing. So if you know this entire thing, it will actually give you a very good idea. Okay, so you will come to know where you are actually working. Okay, so here, anyone have any questions? If you guys have any questions, you can put it in the chat. I'm gonna look at the chart. Okay, I think this is clear. Can you guys confirm once, yes or no? Hello guys, can you guys confirm once, yes or no?
Yeah.
Okay, yeah. Okay guys, so this we will see later. Now, as I already told you yesterday also, what is Google Cloud Platform? Let me gonna just recap. Sir, Google Cloud Platform is a suite of cloud computing services provided by the Google, which are very useful for the organizations to build, deploy, and scale applications and services in the cloud. As I told you already, GCP is one of the leading cloud providers. What it will do, sir, you can just remember like this. You don't need to worry about the definition. So GCP is sorry. So GCP is a leading cloud provider. Cloud provider. What the cloud providers will do? They provide you cloud computing services. These services are very useful for the organizations to build, deploy, and scale their applications and services in the cloud. Okay, sir, can you tell me what are the services that the Google Cloud Platform is providing you? Sir, Google Cloud Platform will provide the computing services, identity and security services, management tools, networking services, big data services, storage and database services, and machine learning services. Okay, Google Cloud Platform provides you plenty of category of services. It provides you the compute services, it provides you the identity and security services, and networking, big data, storage and database services, and machine learning services. Okay, so what we are focusing on, we are going to focus on this area, big data services, as well as storage and database services. So this is our agenda, guys. We are going to focus on these two areas. This is first area, this is our second area. We are going to we wanted to become a GCP data engineer. If I wanted to become a GCP data engineer, we have to GCP data engineer or a GCP big data engineer, both are same, there's no difference. If you wanted to become a GCP big data engineer, we need to focus on the big data tools and storage and database services. Okay, so let us try to go there. And why we need to learn the GCP? If someone asks me, I will say Google has its own community support. Google provides you the services which are cost effective. It is flexible and scalable. So it provides you the flexible services. All the services are scaling up and down as per the demand. So it is reliable services, secure, fully managed services also it is providing. The services are very fast and the interface is very easy to use. Okay, so all of these reasons are already there, so you can able to see it is having a very good community support. The service cost for each and every service in the GCP is very less compared to the other cloud platforms. When you compare the service cost for one service in the GCP compared to the AWS and Azure, GCP's cost is very cheap. So that's the reason I would say cost effective. And it is flexible, scalable, reliable, secure, fully managed, fast. And it is one of the leading cloud provider. That's the reason we also call it as a market leader. Plenty of the organizations or industries are started using it because industry adoption is there from the startup companies, mid-level based companies, MNC companies, product based companies already started using it because of its cost effectiveness. It has its own service portfolio, comprehensive service portfolio. Few of the services I have shown you. It is easily integrate, can be easily compatible with on-premises services, can be easily integrated with other clouds also. It also provides you machine learning capabilities. It provides the infrastructure globally available, very useful for the multi-cloud projects. Maybe today you are using we are in a cloud era. So earlier we used to work on the traditional working model, right? Now we are working in a cloud model, cloud provider, cloud computing era. This is cloud computing era. But the next era is multi-cloud era. So in the multi-cloud era, few of the services from the Google Cloud, few of the services from the AWS, few of the services from the Azure you are going to use. So in that case also GCP is very important for us to learn. And Google Cloud Platform has its own certification and career growth. It provides you the certifications which are very useful for your career growth. Okay, very useful for your career growth. So this is the reason we must learn the GCP. And it has its own growth rate. You can see here comparatively, if you wanted to see the growth rate for the GCP is very high in the last quarter compared to the AWS and Azure. Okay, the growth rate, when I say growth rate, compared to the last year to this year, how many new people started using it? How many new companies started using it? So that is what we call as a growth rate, right? So the GCP is having a very good growth rate. That means plenty of opportunities will be there. And the GCP roles offered: GCP data engineer, GCP developer, GCP admin. Whoever you are, this course is going to be helpful for you. But this course is 100% covered for GCP data engineer, developer, 30 to 40%, because you are going to focus on admin also 30% only. IAM concepts will come into the picture. But for those who wanted to become the GCP data engineer, this course is very useful for you, because we are going to cover 100% of the topics related to the GCP data engineering. And what are the certifications it is providing you? There are two certifications: Associate Cloud Engineer, Professional Data Engineer. Okay, so this is how we are going to start with our very first topic, how to interact with the GCP. If you guys have any questions, you can ask me. So I see that, sir, cloud, what kind of help is taking in DevOps, sir? In DevOps, if you wanted to create the infrastructure, you need the DevOps engineer. I mean, if you in a company, if you wanted to create the infrastructure, you need the DevOps engineer, right? So DevOps means the operations, more of the operations. Okay, so the infrastructure, how do you create it? So that is how it is. Any questions, anyone so far? Please raise your hand if you have any questions. If you have any questions, you can ask me. Otherwise, we can continue with our very first topic, that is how to interact with the GCP. Okay, if I wanted to interact with the services in the GCP, what we have to do, how we can able to interact with the GCP, I am going to talk about it. So if you have any questions, you can ask me. I do not see any questions. That means so far everything is cool. Can you guys confirm once, yes or no? Sir, everything is good. If you say yes or no.
In cloud, what kind of services we can use, and DevOps, what kind of services we can use, sir?
So in DevOps, we are not covering any topics. It's more of a data engineer, okay? It's a data engineer. We are not covering any DevOps topics here. Okay, so all of the services that we are going to cover, as I told you already. So we are going to cover all the GCP data engineering topics only, because the data engineer is supposed to work on the data engineering only. So if you wanted to look at the course curriculum, I'm going to share the link here, guys. Those who wanted to look at the course curriculum. Okay, I'm going to put the link in the chat. So we are not going to cover any DevOps topics, guys. Don't think that we are covering DevOps topics. It is not a DevOps course. It is a data engineering. Okay. But some amount of DevOps will be coming to the picture, like IAM, and GCS, cloud storage, those things will come into the picture. But instead, I would call them as also a data engineering topics only. Okay. So you see here we are covering the topics. So these topics are common, guys. If you go to the DevOps, also these topics are common. Interfaces is common. Locations is common. DevOps also you should know about the locations. IAM and admin also common. You should know about the when you are working as a DevOps engineer, you know the IAM and admin. So these concepts are common. But all the data engineering, our main agenda is to focus on this area. What is data engineering concepts such as the cloud storage, cloud SQL, Bigtable, BigQuery, Dataproc, Dataflow, PubSub, Composer, Fusion, Terraform. So one of the topic from the DevOps is covered, that is Terraform. Very important, because if I wanted to create any kind of infrastructure, nowadays data engineers also should learn about the basic infrastructure creation tool. One of the tool is Terraform. We are going to cover. Okay. So when I say, sir, if you ask me, sir, what are the DevOps concepts covered here? Some of the basic DevOps concepts are covered here. Basics. DevOps basic concepts covered here, guys. When I say not knowledge, it is tools. So GCS is one of the tools. And one more is GCP locations. IAM and admin. I'm an admin, and basics and compute options like compute engine, Kubernetes engine, basics only, cloud functions, the basics, and Terraform. So these are the concepts are covered, guys. When it comes to the DevOps related only, we cover it, we call it as a DevOps related, but it is also very important for the data engineering. So we are covering this one. Okay.
Sir, one question.
Yeah.
What is the difference between DevOps and cloud, sir?
DevOps and cloud. See, cloud is your cloud provider. They provide you the cloud computing services. DevOps is a role. Okay, DevOps is a one role. I can become a DevOps engineer. You can become a DevOps engineer. Cloud is a cloud provides you the services to you. Okay, you utilize it to your organization development. Okay, you can if you wanted to build or deploy or anything. So the cloud is different. DevOps is a role. Okay, DevOps is a one of the role. He is also a developer role. A developer plus operations, he will be going to take care of it. If he is working in the cloud platform, cloud DevOps engineer. That's it. Okay, cloud is a one. You can take AWS or a GCP or a Azure. They are the clouds. They provide you the cloud computing services too. Okay, don't compare them. So there's no comparison between them. Cloud is different. DevOps is different. But one can work on the DevOps engineer can work in the cloud platform. That's how it is. But you don't compare. You don't compare the 10th class guy to the inter class. Okay, you only compare the classes. So I have a once I complete the 10th, I can go to the inter. But it's not that you can't compare them. What are the subjects in the 10th? What are the subjects in the inter? You don't compare like that. Okay, so that's all. So cloud is different. DevOps engineer is different. DevOps is a role. Cloud is a provider. Okay. Yeah. Okay. So let us start with our very first important aspect of our Google Cloud platform with the big data. We are going to cover our first topic, that is how to interact with the GCP. Sir, I am a data engineer. Whoever you are. So this topic is common for all the things, guys. Whoever you are, whether you are a developer, I would say if you are a developer, GCP developer, you are an admin, you are a solution architect or a cloud architect, or you are a data engineer, or you are a DevOps engineer, whoever you are. If you wanted to work in the GCP, how to interact with the GCP is very important. If you wanted to work in the GCP services, how to interact with the GCP is very important for all of these people. So one of us, we are also there, that is data engineer here. So as a GCP data engineer, sir, I wanted to work with the plenty of services in the GCP. As a data engineer, sir, I wanted to work with the big data. Sir, I wanted to work with the storage and database services. How many ways I can able to interact with the GCP services, sir? Can you tell me? If you ask me, sir, if I wanted to work with the GCP services, we can use console. The very first important aspect is console. Sir, I wanted to work with the one more tool that is Cloud Shell. Sir, if you wanted to work with the Google Cloud Services, we have a third method that is SDK. If you wanted to work with the Google Cloud Services, you have a fourth method that is third-party tools. So if you wanted to work with the GCP services, you can use four methods totally. One is console, Cloud Shell, Cloud SDK, and third-party tools. Okay, so let me going to tell you each and every one in a very detail so that it's a very basic concept. You guys have to focus on these important basics, guys. Okay, the very first thing is, usually I call it as a cloud console. Okay, cloud console. So what is cloud console? So this is your cloud console. So I will tell you, sir, how to create a free tier account in the GCP. Don't worry. In our upcoming sessions, maybe tomorrow or day after tomorrow, I'm going to tell you how to create a free tier account. Okay, the basics only we are covering now. So I will tell you how to create a free tier account. Don't worry. So, but once you create your account, this is how your homepage looks like. This is your homepage looks like. So this is your console, sir. This is your console. Now tell me, sir, if I wanted to work with any of the services in the GCP, what I am doing? I wanted to work in the BigQuery. Now what I have done, can anyone tell me what I am trying to do? Can you guys guess it and tell me? Sir, I wanted to create some table. Sir, I wanted to work with the IAM and admin. What I am trying to do here? So what we are doing?
Console.
We are using the console. Console is a visual interface, graphical user interface. By your eye, you are going to look at the each and every service and interacting with that service. Sir, I am a cloud storage. I wanted to work with the cloud storage. By visually, you are looking at that particular service. You are creating a bucket and you are interacting with the services. Okay, by visually, you are going to interact with the services. Okay, so that is what Cloud Console is, a graphical user interface. Graphical user interface. So what is Cloud Console, sir? It is a graphical user interface. Here you are going to interact with the services visually. Okay, visually we are going to interact with the services. How do we interact with the services, guys? Visual. So interaction method is visually. Visually, you are going to look at the each and every aspect of it, and you are going to interact with it. Okay, and one more thing is that actually that is the important step. I would say like this. I don't mention like this. So one more important aspect is that, sir, where it is available, guys? Where did I go? Where the cloud console was available? Where did I go? I went to the Google Chrome. Yes or no? I went to the Google Chrome and I opened the Cloud Console because it is a web-based user interface tool. Okay, it is a web-based user interface tool or web-based graphical user interface to interact with the services visually. To interact with the GCP services visually, we are going to use Cloud Console. What is Cloud Console? It is a web-based graphical user interface to interact with the services in the GCP visually. Okay, so that is what is a Cloud Console, sir. So look at here. See, visually, I'm going to look at here bucket. I wanted to create a bucket. So I click on create bucket. Visually, I'm doing all the activities. I wanted to mention some name here, and visually, all the things we are going to do it. So this is what we call as a Cloud Console. So this page, this entire, you see here, you can also see here console. Okay, so Cloud Console is a visual user interface tool which is available in the browser, nothing but it is browser based or web based user interface tool interact with the services visually. Okay, so what we can do, sir, by visually, you can do anything. If you are a data engineer, if you wanted to create a bucket, okay, if you wanted to create a bucket, you can create it. If you wanted to create a cloud computing tool, you can create it. You can do anything. 1 minute, guys. Okay, so if you wanted to create any bucket, or if you wanted to create some kind of a data proc cluster, if you wanted to create a table in the BigQuery, if you wanted to create a bucket in the cloud storage, or if you wanted to create a SQL instance, or if you wanted to create any kind of a thing, if you wanted to do it, you can go to the cloud console and enable to create it. So the cloud console looks like this, where as I wanted to create a BigQuery table, so I go to the BigQuery. I'll click on here. So I'll click on here. I click on here. So these are the data that I wanted to create table. I can click on create table and create a table. Or if I wanted to create a table, I can mention create table command also. So visually you are going to interact with these services. So that is the reason it is called as a cloud console. Cloud console is a web-based graphical user interface to interact with the services visually. Okay, one is user interface. Can anyone guess it? What could be the other one? When something is interacted by a user interface, can you guys tell me as a developer, what could be one more way of interacting with the services in the GCP? Can you guys guess it? What is our second service? Second method to interact with the GCP? Cloud Shell. Can anyone guess it? How we are going to interact with this Cloud Shell? No one? Okay, let me tell you. So it is also web-based. It is also available over the web, guys. First thing, it is also a web-based, but it is not user interface, but it is a. Can anyone tell me? If something is user interface, the other opposite is command line interface. How do you interact with here? So if you wanted to interact with any of the service in the GCP with using Cloud Shell, you are going to interact via commands. Okay, so Cloud Shell is a web-based command line interface tool to interact with the services via commands. To interact with the services via commands. Sir, it is also a web-based. Sir, you are telling it is also a web-based. Can you show me where I can access the Cloud Shell? If you have that question, I'm going to show you now. But Cloud Shell is also a web-based command interface to interact with the services via commands. So, sir, can you show me? So you mentioned that this is console, but you are telling again Cloud Shell is also a web-based, but can you show me where is the web-based Cloud Shell? So you are seeing here left navigation menu. This is project area. This is search box. This is the free status. This is open duet AI. So here it is. Your Cloud Shell is there, guys. Look at here. I am keeping the mouse there. Activate Cloud Shell option. So this is your Cloud Shell. Web-based Cloud Shell environment. Click on it. Web-based command line interface to interact with the services via commands. Okay, so if you look at here, we have our commands. We have our command line terminal is open, where you can issue a command to interact with the GCP services. Sir, I wanted to list out all the buckets in the Google Cloud storage. Sorry, Google Cloud storage. So you see here how many buckets are there, sir. If I wanted to list out all the buckets in the Google Cloud storage, visually this is what I do. I go to the cloud storage, I click on like this. So how many buckets are there? 1, 2, 3, 4, 5, 6. So that is one. Similarly, sir, I wanted to achieve the same thing with the help of the Cloud Shell terminal also. You can mention gsutil ls. So when you issue that command gsutil ls, you see here, we got the same thing or not? 1, 2, 3, 4, 5, 6. So gsutil ls is a command. We must know the commands, right? So if I wanted to interact with the GCP services, we must know the commands. If I wanted to interact via Cloud Shell, we must know the commands. So these commands are Linux-based commands only. So we are going to discuss few basics of Linux in our upcoming sessions. You don't worry about that. Okay, you don't worry about that, because in our upcoming sessions we are going to cover basic Linux concepts. So here it is, Linux basic concepts. 10 commands are there. You must focus on those 10 commands. Okay, that I will tell you, don't worry. And now, so look at here, Cloud Shell. With the help of the commands, we are going to interact with it. Now we have just interacted with one of the one of the service called cloud storage. We have interacted with it. Similarly, sir, I wanted to interact with the BigQuery. Sir. Can you tell me what is the command to, how many buckets, how many data sets are there? In BigQuery, we have 1, 2, 3 data sets are there, right? Sir, I wanted to list out those data sets, BQLS. See, now we have interacted with the BigQuery. So BigQuery, BQLS, bronze dataset, silver dataset, the sample dataset. Sir, I wanted to see the tables inside this silver dataset. Okay, I wanted to see the tables inside that silver dataset. See here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, look at here. You can also go to the silver dataset. You can see. Okay. Oh, it's showing actually. Yeah, these many data sets are also there. Tables. Inside your silver data set, 1, 2, 3, 4, 5, 6, until this many tables are there. Okay, so that is how you can able to. If you wanted to look at the code also, if you wanted to see the data also, you can mention BQ, select a star from that particular table. You can also view the data as well. So if you wanted to insert the data also, BQ load command you can use. So if you wanted to, as a data engineer, sir, I wanted to load some data to the BigQuery, you can do that using the command line tool as well. You can do that using the console as well. You can do that using the command line tool as well. You can use that you can do the same thing using the SDK also. You can do the same thing using the third-party tools also. So that is the reason you have totally 4 methods to interact with the GCP services. Totally 4 methods are there. Where we are stand now, we are learning about the Cloud Shell. In the Cloud Shell, it is a browser-based command line interface to interact with the services via commands. Sir, I'm telling you, one or two times it's because these are the very basic commands. So you must know tomorrow what is Cloud Shell. If you ask me, then there is a problem. That means you are not listening. So that's the reason 1 or 2 times I'm explaining each and everything. Look at here. Now, sir, but when I look at here, I went to the Cloud Shell, but I activated the Cloud Shell, and when I see here, it is showing Cloud Shell terminal. But here we have a one more option, editor also, open editor. Sir, what is the difference? Sir, what is the difference? When I click on editor, it is opening Cloud Shell editor. So what do you mean? Do we have 2 things? Yes. Okay, we have 2 things. In Cloud Shell, you have 2 phases. In Cloud Shell, you have 2 phases. The very first phase is Cloud Shell terminal. And the second thing is you have editor. Okay, terminal is purely to run your commands. Editor comes up with a what we call versioning. You can do the versioning of your code. You can write your code. You can do the Git operation. So many things are also there. Okay, so terminal is purely to run your commands. Editor comes up with the editing option. You might have already known that, right? IDE. It is more of IDE, guys. You can say it's more of IDE. Okay, comes up with the Git features also. IDE means integrated development environment. Okay, so that is how you can look at here. If you go to this particular phase, I think it's still opening. Okay, let's make. Okay, it is still opening. Yeah, this is how it is. So you can see here it is IDE. Integrated development environment. Sir, I wanted to write a Python code. You come here, you click on new file, you create a new file, main.py, main1.py. You click on main.1.py. You create a code here, print welcome to GCP data engineering. You write this command. You go here. I wanted to run that command, sir. Can anyone tell me how do we run it, guys? First, we check it. Do we have that code? First thing. See here, main.py, main.1.py. So it is using Python. I wanted to run it. But look at here. Do we have Python here or not? First thing. Sir, is Cloud Shell comes up with the pre-installed Python or not? Let me check it. Python hyphen version. Look at here, guys. Python version is already available. That means on top of the Cloud Shell, pre-installed softwares. It comes with the pre-installed softwares. Python, Java, Terraform, Docker. So, what is actually the Cloud Shell? If you have to understand what actually the Cloud Shell is like your virtual machine. Okay, so Cloud Shell is that by definition wise, Cloud Shell is this one only, browser-based command line interface. But to actually go deeper and try to look at the Cloud Shell, it is a virtual machine assigned to each user. Okay, it is a virtual machine assigned to each user, sir. Okay, it is what, sir? It is one of the virtual machine assigned to each user. And one more advantage is that this virtual machine comes up with the pre-installed client libraries. Okay, client libraries already installed here. Client libraries. What are those, sir? Can you say Python, Java, Go, Terraform, Docker? So plenty of these softwares are already pre-installed. You don't need Kubernetes, kubectl, CTL. So plenty of commands, plenty of client libraries already installed. You don't need to specifically install if you wanted to use. Okay, so that is what is your Cloud Shell, sir. Actually, how the Cloud Shell was created, it is one of the virtual machine assigned to the each user, whoever it is. It is one of the virtual machine. So this virtual machine is created for each and every user who is working in the Google Cloud platform. It created for each and every user in the Google Cloud platform. Okay, so this is one of the virtual machine created for each and every user in the Google Cloud platform. That's perfect. Now tell me, sir, you are saying it is a virtual machine. What is the storage of the virtual machine? 5 GB. Okay, the storage of the virtual machine is 5 GB. Okay, so this is what is the storage of that particular virtual machine. And as I told you, it comes with the pre-installed client library. You can go here. Earlier we have created main.py. If you remember, we created this main.py. So you open the terminal. And sir, ls I give. So I wanted to run this command, sir. Print, Python main.py. So you run it. What we are printing here, look at here. Welcome to the GCP data engineering. It is printing or not. So you can able to run that. Okay, you can able to run your Python code, Java code, anything, sir. You can able to run it. Okay, so that is how you have to understand that Cloud Console is a web-based, Cloud Shell is a browser-based. Cloud Shell is a browser-based interface to interact with the GCP services via commands. And actually, if you look at the definition, this is what it is. But if you wanted to look at deeper, sir, what actually the Cloud Shell? If you ask me, the Cloud Shell is as one of the virtual machine assigned to the each user. It comes up with a pre-installed library, client library such as Python, Java, Go, Terraform, Docker, kubectl, and it comes up with the 5 GB persistent disk storage. Okay, if you wanted to store anything until 5 GB, you can able to store it. Okay, so this is what is a Cloud Shell, sir. And I already told you, Cloud Shell has two phases. Cloud Shell has two phases. One is this one, and one more is this one. One is Cloud Shell terminal, one more is Cloud Shell editor. Terminal to run your commands purely. Editor comes with IDE where you can able to do the integrated development environment. Okay, so you can go here, editor. And here it is having version controlling, source code control also it is there. So version controlling, you can go for Git also, Git operations also. Plenty of things are already here. Okay, so that is how it is. Okay, yeah, so we have completed this one and this one. Tomorrow we will see the third and fourth. I'm going to stop it here for today, guys. Hope you got some idea on what is console, what is Cloud Shell. Okay, so that is what it is. So if anyone have any questions on the any of the topic that we have discussed so far, or any of the questions on the course content, you please raise your hand. Please raise your hand, guys. I wanted to. Please put the question in the chat also. I will go one by one. If anyone have any questions. Okay. So far we have discussed why we need the cloud platform and the difference between the traditional and working model and this one and interaction methods we are going to cover. Okay. So one of them, I want to ask about the projects offered in this course. So you can go to my course as I told you already. So see here, guys. So if you can go here, data engineering, the main projects covered. This is one, this is two. Okay, these are the main two projects, but end-to-end pipelines are many. If you go to here, so we have job 1 and job 2, one end-to-end pipeline. So one more is end-to-end pipeline. If you go to the data flow, also end-to-end streaming pipeline. If you go to the airflow, you have a level 1 DAG, level 2 DAG, level 3. These are the end-to-end pipelines only. So if you can go to the data fusion, end-to-end pipelines are many. Okay, so you don't need to worry about it. End-to-end pipelines are there. But end-to-end full-fledged projects is also covered. 1, 2. Okay, you can use this thing. Okay, many end-to-end projects. Instead of project, we call it as a pipeline. So end-to-end pipelines are many end-to-end pipelines are covered here. Okay, yeah. Yes, anyone have any other questions, guys? Is there any programming we need to do? Of course. Sir, this is a programming job only. We need to write the code in SQL and PySpark. Okay, we need to write the code in SQL and PySpark only. Okay, yeah. So I think the two questions I have answered. We will be covering the incremental loading, of course. Sir, I am a SQL DBA. In interviews, they asked me to learn the cloud related issues. So if this is helpful for my future related admin, of course, this course is very useful for you. Of course, yes, because we are going to cover about the cloud SQL where you are going to see our DBA activities. And one more is that we are going to cover the IAM and admin concepts, which will be very useful for you as an admin. Of course, yes, this course is very useful for you. You can say that I have learned this course also in your, and which will be very added advantage for you when you're working in the same company. No, sir, I wanted to come outside of the company and look for the opportunities. How do we say? In that case, also you will be having a plenty of opportunities. Okay. Yeah. Yes. Anyone have any other questions? Can we get the notes, sir? Once you have completed the registrations for the course, I will provide the access to the notes. Okay, notes access will be provided to you, all of you, once the registrations are completed, and I will add it to you in my mail. I will, so that you will be able to have the access. Okay, I will provide the access to you guys, for all of you. Yeah, anyone have any other questions? Can we get detailed project content breakdowns? And brochure does not have a detailed breakdowns. Which one? About the project content. See here, I don't mention all the things in the brochure, right? So usually, if you can go to my notes, that is mentioned here. If you can go, you will be having resume templates, you will be having interview introduction. I can't mention all of these things, right? So you see here, this is project one, the description architecture diagram, project two, description and architecture diagram, data engineering questions and answers, SQL questions and answers, Python questions and answers, certification end-to-end project, live video. I have explained flow and what are the setup and everything. So, and if you go to the BigQuery, you have a case study one, case study two, and you have assignments. And data proc, if you go, you have a case study one, case study two, case study three, assignment one, assignment two, end-to-end pipeline. This is your pipeline, what you have to do. The descriptions also mentioned. If you go to the data flow, you have a lab sessions. There you will be able to see the job one is already covered, and into template method of creating the pipelines, batch pipelines, streaming pipelines, and end-to-end streaming pipeline covering all the application topic, subtopic. We see here Python application, Google Cloud Sub, Cloud Data Flow, Cloud BigQuery, Cloud BI tools. So all of these things are integrated, and an entire pipeline is created using the streaming. This is a streaming pipeline, and Airflow. You see here. So level one tag where you'll be seeing the moving the data from the BigQuery. This is BigQuery to the BigQuery. This is where we will be covering the STDs. And level two, here we are covering the composer scheduling, where we were scheduling the data proc jobs. That means PySpark jobs. And this is where we are learning about the parent DAX assignment. Here you will be going to learn about Cloud SQL, Google Cloud Storage, BigQuery, raw table, BigQuery Insight table. So everything is already covered here, guys. I'm telling you, it's a very detailed course, so you don't need to worry about anything. So the basic knowledge is SQL, guys. If you learn the SQL, that is more than enough. For this course, the basic thing is SQL. So if you are already having a good knowledge on the SQL, that is more than enough, because almost all the concepts are related to the SQL only. Because data engineering means SQL and PySpark. PySpark I will be detailedly discussing in our sessions here. Okay, I see some question in this. What topics I have to concentrate more? It means data admin concepts. So I will tell you guys. So for example, if you while we are covering, I will tell you for most of the concepts like storage and IM and admin locations. Okay, so the interfaces, and as a admin, you are going to how you have to set up the admin activities for the BigQuery, data proc, data flow, because it's not different. Okay, it's not different, but you don't need to, as an admin, if you wanted to go, you don't need to go for coding. And for the admins, I suggest you don't go for admin. It's because your packages will be very less compared to the developers. So if you are willing to learn this course and go as a data engineer or a big data, then your package will be very good comparatively. Okay, but for sure, few of the basic concepts related to the admins also covered here. Yes. Yeah. Yes, we are going to cover main big data and storage concepts only. Yes. Yeah. Anyone have any other questions? If no, we are going to stop the session here for today, guys. We are going to discuss few more topics tomorrow. Okay? Yeah. Any questions, anyone? Yes. After this course, you can take the PDA certification for sure. Yes. Sir, as a source, we will be working on the data sources, applications. We are working on the databases. Okay. We will be taking care of Parquet, Avro. So those also we are going to cover. Yeah. You can go and look into it. For example, if you wanted to see lab sessions, you can look at here. So these are the data sources: JSON, CSV, Avro, Parquet, Excel file, BigQuery table, and MySQL also is supposed to actually mention here, because you can see here MySQL also it is mentioned. Okay, so such kind of a databases, tables, CSV files, Avro, Parquet, JSON, many things we are going to cover. Don't worry about that. Okay, yeah. So whatever you name it, guys, everything is already available. I can say something which is covered, but if it is not available in the if whatever I am saying, if it is available in the notebook, that is only I am covering, sir. If it is, even though I am saying it is covered, if it is not there in the notebook, that means I am not covering. I don't need to bluff you saying that it is covered and tomorrow it is not covered. I don't need to say anything. And if you have anything, you can actually come to my notebook. Sir is covering, yes or no. You can just come down here. If I'm showing you here something, that means it is covered. Okay. Yeah. Whatever you have asked so far, you guys, I have mentioned here, that means it is covered. Yeah, I'm ready to join this course. Do you have any upcoming course in the evening time for next month? Not sure, guys, for the next month. But yes, sure. You can connect with our admin team. Maybe in the next month, evening batch may start, but it takes time. At least 30 to 30 days it's gonna take. Okay. Yeah. The procedure. What is the procedure for GCP certification? So certification is like $200. You have to enroll it. You have to attend the exam. That's it. If there's no procedure, you just have to go to the there is this link called web assessor. So if anyone wanted to take an exam, certification exam, you have to go to the web assessor. I forgot that web assessor. Yeah, you have to go to the web assessor. You have to log into the web assessor. You have to create your own account and select the GCP certification and pay the $200, and you can go for the exam. Okay, so that is what you have to do. Web assessor. Okay, yeah. Certification is easy or it's difficult to crack? Do we need any real-time experience? No, no, no. Certifications are easy, guys. Certifications are easy to crack. So if you actually go to my dumps, so my student says that, sir, these dumps are very useful for me. Some of questions are already repetitive. 15 to 20 questions are repetitive. They say. Okay. So you can go to the certification dumps. These are very good. You can go and utilize these dumps. These are repetitive. The questions are repetitive. Okay. Okay, guys, I think we're good. We are going to have our third demo, which is also very free. We are going to cover tomorrow. So if you have any questions, you can ask me in the tomorrow session also. No worries at all. And I'm going to stop the session here today. Tomorrow we will see what is Cloud SDK. And after that, we will eventually start the GCP locations concept. Okay? Yeah. Any questions, anyone? Okay, I see no questions. Okay, guys. Thank you all. Have a great day. We will meet tomorrow at the same time. Bye-bye. Don't miss the tomorrow session.